Okay, so this is a question that asks us to draw a transition state and use the Hammond postulate to sort of give us guidance as to what that transition state looks like. So this is a rearrangement. So from the isobutyl cation to the tert-butyl cation. So here we have a primary carbocation going to a tertiary carbocation. And since the tertiary carbocation is much more stable than a primary, we can say that this is an exergonic reaction. So if we wanted to draw an energy diagram, we would have to put, so this is energy and this is the reaction coordinate. And if we were going to put the isobutyl cation on this energy diagram compared to the tert-butyl cation, it would look like this. The tert-butyl cation is much more stable than the isobutyl cation. Tertiary, primary versus tertiary. Now, in the process of getting from the primary to the tertiary carbocation, we always draw a curve that shows an energy of activation or a transition state with its associated energy of activation. So this is the energy of activation. And this is the transition state here. Now, which is represented by a double dagger. So the question is, what does that transition state look like? And of course, it's going to have partially formed bonds, partially broken bonds, but we know, at least by the Hammond postulate, that this structure, the structure of this transition state, because it's an exergonic reaction, must resemble a primary carbocation more than a tertiary carbocation. Because remember, the definition of the Hammond postulate is that the structure of the transition state resembles the nearest stable species, whether that's an intermediate or a product or a reactant. In this case, it's probably an intermediate because we got to this somehow. We got to this cation, presumably under some sort of acidic conditions, but we're just looking at this rearrangement step. And this is quite high in energy, this primary carbocation. And because this reaction is exergonic, and it's very exergonic because the tertiary carbocation is so much more stable, then the transition state here must resemble the reactant in this case, the primary carbocation, much more than it resembles the tertiary carbocation. So how would you draw that? Well, it's kind of hard to draw, but let's just draw the carbocation as if it were sort of as if these were equal in energy and the transition state resembled neither the primary nor the tertiary more than the other. So here is the tertiary. Let's just draw CH3 here for these methyl groups. And this is actually, we're going to start with our primary carbocation. So let me I'll draw the primary carbocation first. And so this would be CH3, C, let's have that coming out, H3, and then this would be H, and then the primary carbocation would be this here with a plus charge there. So this is our primary carbocation. Now, in the transition state, this bond is being broken, right? And there is a new bond, so I'll just put this in partial bond dots here. And there's a new bond being formed. And this plus charge is sort of shared now between this. There's a partial plus here and a partial plus there, between the tertiary center and the primary center. Now, if there were no preference, or sorry, if there were no, if the energies of these two happen to be the same and the transition state resembled neither one more than the other, you would simply have the H right in the middle and then delta plus and delta plus shared equally between these two carbons. But since by the Hammond postulate we're saying that the transition state resembles the primary carbocation more than the tertiary, then we would have to say that we have more of a bond here, which this is sp3 hybridized. So that's an sp3 orbital with the s orbital and hydrogen, and maybe a slight positive charge on this carbon, but for the most part, you still have your carbocation there, and a very small amount of bonding between this hydrogen and this carbocation. So essentially this is saying that we have, and this is just a p orbital there, we have mostly carbocation character on this carbon and mostly sp3 character on this carbon, but there is some degree of bonding happening. It's probably on its way, just ever so slightly. The hydrogen is on its way over. So it's about to cross over and form an sp3 type of interaction with this carbon, and the carbocation move on to the tertiary center, but it's mostly at the primary carbocation stage.